show today by turning your attention to the massive machine in the center of the stage. This is the world's largest air-insulated Van de Graaff generator. It was originally built in the 1930s at MIT in order to study the structure of an atom. We use it here today in the museum in order to produce our indoor lighting. So I'm going to begin the show today by actually turning that machine on so that we can all get a little taste of what that is going to look and sound like. I'm putting on my hearing protection for this. I highly advise you cover your ears as well.
I don't know, man.
So there is a small taste of what we're going to be experiencing throughout the
small taste.
If you found that a little bit too bright and loud, I have some bad news for you. It's only going to get brighter and louder from here. You may want to take advantage of those exits. If you did
O sea que va a sonar más duro.
I have some good news for you.
Me voy de acá mejor.
Brighter and louder from here, culminating in what we refer to as our symphony of the park, where I turn on as much of the stage as I can at once.
Va a sonar allá abajo, creo que esa bola de abajo, con esa de arriba, entonces va a sonar duro. Ajá. No creo que suene tan duro porque mañana muy cerca estamos.
A few hands up in the crowd. Well, it turns out that all of us with our hands up right now are dead wrong. And that's okay. Science is a learning process. Hopefully you have come to the Museum of Science today to learn a little bit. And lesson number one is that the electric force is both invisible and silent. What we have just observed are the effects of the electric force. We can compare it to another force that we are all currently experiencing, the force of gravity. Now, none of us hears or sees the force of gravity pulling us towards the center of Earth's mass. It is also a silent and invisible force. And yet, we are all currently experiencing the effects of that force. We are all sadly tethered to the surface of the Earth. And just like we're all currently experiencing the gravitational force, we are also all currently experiencing the electric force, just generally on scales where the effects are not observable. And the reason for that is because the electric force moves electric charge. An electric charge is present in every atom and every molecule in our bodies, and in all the matter in the room around us here today. So you're probably familiar with this. Electric charge comes in two different flavors. We have our positive charges and our negative charges. And those opposite charges attract toward each other, and they move via the electric force. But if we have large numbers of positive and negative charges, and those numbers are equal, well, then those charges are said to be in balance, and there will be no net movement between them. But if we happen to get an overabundance of one type of charge, say too many positive charges or too many negative charges, well, then those similar charges repel away from each other. And again, they move via the electric force. So in the case of our Van de Graaff generator here, this machine is not actually generating an electric charge. Rather, what it's really good at doing is separating out and collecting negative electric charge. And it does so by first taking those charges from a plug in the wall, ground underneath our feet, takes all those negative charges and pushes them up the massive wooden columns and deposits them all on the metal domes at the top. And as those negative charges collect more and more, they begin to repel away from each other with greater and greater force. And they're seeking to come back into balance with positive charge. Well, the easiest place for them to do that is the massive supply of positive charge that makes up the mass of the Earth underneath our feet. So they're seeing a path down toward the ground. Well, we sent up a little probe, which was connected to the ground, and negative charges repelling off the Van de Graaff came in contact with positive charges on that probe, and when that happened, a channel opened up. There was a massive movement of negative electric charge from the Van de Graaff to the probe down to the ground, and the effects of all those charges moving all at once was our observed spark, that bright flash of light and that loud popping sound. And then each subsequent flash and pop was that entire process repeating over and over and over again. So that's one of the ways that we can observe the effects of the electric force. We can also do so with a slightly smaller machine, a little bit closer to the front of the stage. These are Tesla coils, and they also produce electric sparks, but they do so in a slightly different way from the Van de Graaff. They too are taking negative electric charge from a plug in the wall, but they're taking those charges and they're tossing them in between some capacitors in order to increase the amount of energy throughout the system. And once this coil has hit a certain electrical threshold, those high energy charges are then all shot out the top of the coil. And once again, all those charges moving all at once produce our two observable effects: a light we can see and a sound we can hear. However, just like the charges that were coming off our Van de Graaff generator earlier, the charges currently coming off this Tesla coil are not going to stop moving until they come back into balance with positive charge. And just like with the Van de Graaff, the easiest place for them to do that is the massive supply of positive charge in the earth underneath our feet. And so these charges actually continue to move well beyond our ability to observe the effects of their movement. However, we could observe those effects if we just had the right piece of equipment. And in this case, the right piece of equipment is going to be this light bulb, which when charge passes through it produces a visible effect. So what I'm going to do is change my camera angle a little bit here so everybody can see what's going on. Dim the lights a little so we can see this light bulb a little bit better. And then I'm just going to walk toward this Tesla coil until we observe a change. Oh, no. That's interesting. So here we are, again, observing the effects of the electric force. In this case, the movement of electric charge from the Tesla coil down to the ground. Now, initially, we observed those effects as all those charges come rushing out of the Tesla coil all at once. But then all those charges begin to take separate paths as they all seek alternative routes down toward the ground. Well, when I get close enough with the Tesla coil with this light bulb, something special happens. A number of those charges find the same relatively consistent path. That is, through a little bit of air, through this light bulb, through me, and down into the ground. We can further observe that those charges are using me as a pathway if I grab this light in a slightly different place, and now we see that those charges are only moving through about half the bulb before they jump to me and make their way down to the ground. We can also observe that as I step further away from that Tesla coil, the light becomes significantly dimmer. That's because fewer of these charges are able to make this huge distance through the air before they find an alternative path to the ground. So that's one of the ways that we can observe the light effect produced by the electric force. I also can make, or we also rather, can make observations on the sound effect produced by the electric force. So I want everyone to just sort of listen to this Tesla coil for a moment. Sort of a dull, consistent hum. Now that sound is being produced in the exact same way that our Van de Graaff generator was producing sound earlier. That is, every single time that this Tesla coil releases a spark, there is a single accompanying pop. The difference is that with the Van de Graaff, we were only releasing 1 or 2 sparks per second, so we could hear the individual pop, 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 pop. This Tesla coil is currently releasing 120 sparks per second. And those sparks and accompanying pops are coming so fast that it's actually impossible for our ears and brain to interpret the individual pops. And so what we hear is just one dull, consistent hum, or one note, if you will. But if we could actually change the number of sparks that that Tesla coil was releasing per second, we could change the pitch of that note. And that is the point of the much larger Tesla coil behind the one we've been making observations on, this giant 8-foot copper column in the back with the 2 silver donuts on top. That also releases sparks out the top, but it has an additional electronic gate on it, which allows us to control the number of sparks it's releasing. And it turns out that if we release more sparks, or fewer sparks per second rather, then the pitch of that note is going to get a little bit lower. And if we release more sparks per second, the pitch of that note is going to get a little bit higher. And so by very precisely controlling that, we can produce sounds like this. I'm covering my ears for this. I highly advise you cover your ears as well. All right, turns out this is a classic case of make sure your equipment is warmed up before you make a big promise. So I'm actually going to review the thing here a little bit, apologize for that, and then we'll actually hear what they have to say. All right, now we can make some pretty impressive sounds. Here we go. All right, it looks like it's really upset with me. Good thing we started early. I'm going to get this right. Thank you. All right, we're going to warm it back up and then we're going to give it one more try here. We did get one impressive note from it. You might have heard it. It's pretty spectacular, I thought. All right, third time's the charm, putting on my hearing protection. Let's see if we can get it this time around. All right, I have one more trick that I can pull, which is to completely close out the program. Try it again. So we'll try that one more time, and then I'll do some other impressions like this. Don't worry, we'll get something out of this. So the idea here is similar to what you might experience from a musical instrument, right? When music is played, it produces different notes by vibrating the air at different frequencies. That is what's supposed to be happening with my computer here. That's supposed to be what's happening with my Tesla coils over there.